Okay, so that's one last person in. I think that's probably a reasonable number to be getting going with. So let me thank you all for coming and welcome you to this talk in the CAIDA AI in Society series. Today, I'm delighted to introduce Jonathan Herington, who is speaking to us from New York, from the University of Rochester. And Jonathan has done work on really a very broad number of topics, drawing on social and political philosophy and ethics, and really engaging with research in various kinds of AI, rather than just applying the philosophical theories to this case, really drawing on the science in a distinctive and useful way. And he's going to speak to us today about affective computing. Just a reminder for those of you who have not been to so many of these, that in philosophy, the general norm is to leave questions to the end. And hopefully we'll leave plenty of time for those questions to be raised. If as we go along, you do have just a quick clarificatory question, raise your hand in the normal way. But let's try and leave substantive discussion to the end. Okay, with that said, Jonathan, take it away.
All right. Well, thank you so much, Christopher, and the other folks at CAIDA, first for that wonderful introduction, and then second for inviting me to give this talk. I looked up some of the other philosophers that have contributed to this series, and I'm extremely flattered because many of them are pretty eminent people in our field in applied ethics, and so I'm extremely excited to talk to you here. I'd also like to thank Aaron for doing all the legwork, organising all this. She has done an exemplary job herding cats to get us all here. So what I'm going to do today is I'm going to talk about a new project for me. It's in its very early days. In fact, this is the first time I've presented this work to folks. And it's a bit of a departure from areas of machine learning or areas of applied science that I've been interested in before. So that is just a little flag to say I will gratefully accept criticism, redirection, even really trenchant criticism of what I'm about to talk about now. And in particular, if there are particular features of the empirical work that you think I should know about or that you think are relevant to the discussion today, I would love to hear more about them. Now, the basic summary of what we're going to talk about today is I'm going to talk about affective computing in general, but I'm going to narrow down to think about a particular use case, which is what I call facial sentiment analysis, or what's sometimes called emotion recognition research in computer vision. And we're going to talk a little bit about the ethical problems that raises, and two kinds of views that have cropped up about facial sentiment analysis. One which says that research into facial sentiment analysis should be avoided, that it is a hopelessly broken paradigm that ought not be pursued. And another which says, no, listen, this is early science that is being done in the context, that is not quite ready for prime time, shouldn't be deployed, but should nonetheless be pursued in a research context so that we can refine and reform facial sentiment analysis until it is ready to do the things that we want it to do. And I think these two views that have kind of started to solidify in the research and activist communities are a little bit too coarse-grained. And I think what we can do better than this, and I think one way we can do better than these two coarse-grained positions is to look at the reasoning behind one of those views, permissivism. And here's my cat, that's the cat tax that everyone pays at a talk on Zoom now. We're going to talk about one of those views, permissivism, and we're going to look at two sets of idealizations that it makes about the context of science and about the conduct of science. And we're going to use those two sets of idealizations to see the ways in which those idealizations are false, and then unpacking why those idealizations are false might help us map a way of reforming facial sentiment analysis research and ultimately resisting abolitionism. So, a brief overview of the problem. So what's affective computing and why do people worry about it? So the promise of affective computing is something like this. Affective computing is a way of identifying, interacting with, producing human-like or human emotion. And the kind of ultimate goal is to help realize kind of more effective and humane computer-human interaction. And that gets cashed out in a number of different use cases, right? You can think about why would we want to identify human emotions or be able, or have a machine be able to recognize those emotions? Well, because we want to assist neuroatypical people in communicating with other people in their day-to-day interactions, right? Or maybe we want to ensure that our digital or robotic assistants have appropriate affective fit for the individual that they're dealing with or for the particular circumstance, right? You might think that you can use it for mental health crisis and detection. It's sometimes thought to be useful in the context of things like auto-moderating harmful content on the internet. And then you know, there are other applications as well, like AI therapists or assistive robots, right? Now, with the kind of promise, so all of those things I think seem pretty promising, or seem like something that we might want to pursue. But there are kind of 4 areas that I think have really raised questions, or that people have worried about in the context of affective computing. And we'll think about these as the 4 horsemen of affective computing. So one of them is literal Ai Phonology, which is the phrase that Kate Crawford used to describe algorithms which attempt to predict behavioral traits or dispositions simply by looking at photographs or images or video of an individual. And we'll talk about a few of those in a second. Another is facial sentiment analysis, which instead of attempting to predict stable behavioral traits, instead simply tries to predict people's affect or emotion. And that uses images or video to do so. There's a textual version of that, which is pretty popular amongst people who are into natural language processing, right? So Facebook has this kind of sentiment analysis algorithm to help it triage its moderation of content. And then there's also this, this concern about affect modification applications. So AI therapists or mindfulness apps that are explicitly designed to intervene on people's emotions. There's a concern about what that intervention looks like and whether it's legitimate and how it might be directing people into different affective states. And I think, broadly speaking, there has been a whole bunch of condemnation of literal AI phonology in the press and also in the research community. This has not been particularly popular. Amongst the research community, though, there has been kind of widespread acceptance of the legitimacy of textual sentiment analysis and attempting to construct affect modification applications. People recognize that these things have ethical problems or issues with them, but they in general support the research into the improvement or modification of these kinds of applications or algorithms. But there has been a big question that's been raised about whether or not facial sentiment analysis is permissible, right? Whether or not we should kind of abolish or restrict, or whether it is intrinsically unethical to conduct research like it is commonly assumed to be with literal AI phonology, right? Or whether facial sentiment analysis just needs to be carefully constructed and vetted over time, right? So to give you a feeling for what's at stake here, let's just talk a little bit about literal AI phonology. So here are 3 quick cases. And this is relevant because literal AI, the AI facial prediction of behavior has been strongly associated in activist circles with facial prediction of affective states or emotions. Right? So the classic example of this is the automated inference on criminality using face images, paper in 2016, and a follow-up study in 2020 where they attempted to look at the facial detection of criminal tendencies and the impact of gender bias on the capacity to detect criminality in inverted commas from facial images. So both of these papers are kind of fundamentally flawed. They explicitly reference the theory of Cesare Lombroso, who is the father of criminal phrenology, who invented the science, in inverted commas, of phrenology, of criminal phrenology in the early 20th century and late 19th century. In the case of the 2016 paper, at least, they used this kind of obviously biased data set where the criminals' face photos were ID photos, whereas the non-criminals were kind of promo headshots. So there was like already a way to kind of quickly distinguish between them. That's almost certainly what the algorithm was picking up on. They were both of these have been kind of widely condemned. Although interestingly, the authors of the 2020 study both still have very fancy tenure track positions. So that's maybe a strike against meritocracy. The other famous paper in this class is the Gaydar paper, the AI Gaydar paper, which claimed that it could, which was trained on a labeled data set of heterosexual and homosexual images of people who are labeled as heterosexual or homosexual, and it was roundly condemned when it was created, right? And then finally, you also find sometimes things that are not quite as obviously bankrupt as the criminality predictors and the Gaydar predictors, right? But instead try and identify quite well validated personality characteristics, right? Like the big five, but simply using facial imagery, right? So the basic idea here was that they tried to predict a real trait, the set of big 5 personality traits, simply using photographs of college students. You'll see that they claimed that they could have 90% accuracy for neuroticism and extroversion. And the problem with this paper, if there is one, is that it's a kind of theory-free investigation of the issue, right? But the kind of latest work says that, you know, this little quote down here is from a paper that was published recently in Nature, that there's really no genetic evidence for the supposed predictive value of face shape on behavioral or cognitive traits. And so it's just not clear why you would expect a simple photograph of a person's face to be able to predict things like neuroticism, even if the underlying behavioral trait is real, right? Or is a construct that we think is valid. So alongside these have been a set of algorithms that have also cropped up, and these that are not as controversial, but are much more widespread, right? And these are algorithms that attempt to predict not behavioral traits, but instead affect or mood from still or video images. And these do have some theoretical backing. We'll talk a little bit about the quality of that theoretical backing in a minute. But they're all based on a theory of emotion called basic emotion theory that was developed by Paul Ekman in the 1990s and throughout the aughts, that claims that there are stable stable indicators, cross-cultural indicators of emotion across that are visible on people's faces, right? And packages that try and attempt to do this, attempt to predict people's emotion from imagery or video, have been created by Microsoft, Amazon, Google, and it's like a staple of the small AI consultancy business, right? So this still is an example of what you might expect, which is this is a video where the emotion recognition technology of Velosa, which is a random Finnish AI consultancy that I picked out of a hat, markets. And you can see that what it's doing is it's attempting to identify what are called basic emotions, the probability that the face is exhibiting a particular basic emotion there. It's not doing a very good job in this image, right? So this guy is clearly just concentrating. He's not angry. It's not clear he's happy or sad, right? He should have a high score for neutrality, but for whatever reason, it's not particularly accurate. And the idea with these is that there's applications for it in terms of meta tagging for social media, XR assistance for people with ASD or face blindness. You can use it to try and track the satisfaction of your customers in store. So one of the applications that's sometimes talked about is you can have a special CCTV system that enables you to review the satisfaction of your customers as they wander around your aisles to see whether they're made happy by the way the place is laid out, right? And then you can also somewhat more dystopianly track employee affect or mood, right? In open office environments or through these wonderful Zoom cameras that we have right now. Okay, so facial sentiment analysis has raised a couple of ethical issues, right? So the first is that it's unclear. The Ekman basic emotion theory is controversial, to put it lightly. And in fact, there's a well-known critic of this is Feldman Barrett at Northwestern, who has published a paper basically rejecting the idea that there's a stable cross-cultural way of inferring sentiment or affect through facial features alone. But beyond that kind of basic theoretical dispute, you can see how there's kind of a large latitude for bias in the labeling of photographs, right? So if we ask human labelers to label our data set, they're going to inject all sorts of gender and racial and cultural biases into the labeling of data. There's a large latitude for kind of cross-cultural flattening. So, the presumption or assumption that the modes of expressing particular affects or emotions in Western cultures are universal, right? And there's a high likelihood of the use of this in kind of high stakes settings like criminal investigations, mental health diagnosis, employee performance tracking, et cetera, et cetera. And you can see the racial bias question is not just a hypothetical. This is an analysis of the FACE++ emotion recognition system. And you can see that it systematically, you can see that it's not very accurate with respect to certain kinds of emotions. And the other is that it systematically overrepresents negative emotions for Black subjects. So higher rates of fear, surprise, and anger, lower rates of smiling and happiness, right, relative to their white counterparts. And this has led some, the AI ethics researcher and cognitive scientist Abida Berhane to talk about, listen, it's not just that these algorithms are biased, it's that when we call them biased and inaccurate, it kind of underplays the fact that emotion recognition technology is simply digital phrenology, right? So her view is that this is as theoretically and morally bankrupt as the actual AI phrenology cases. So these are the cases that I'm interested in, right? The cases of automated facial sentiment analysis itself, right? And there's a typo there. Instead of, it should be FSA. And there are two big views that have coalesced. One is abolitionism, right? And this view says, listen, FSA should not be pursued by researchers. Fundamentally, it's bad science. It's based on a discredited theory. The data is hopelessly biased. And the machine learning, utilizing machine learning isn't going to improve the underlying theory, right? We're not going to get new theoretical insights from applying machine learning techniques to iterating on machine learning techniques over time, right? The second is, it's not just bad science, it's going to be used unjustly, right? It's going to be used to penalize the disadvantaged, even if we manage to remove the racial and gender biases that are embedded in the data sets, right? So again, here's Dr. Berhane. It's frustrating to see ideas of scientific racism and eugenics regurgitated again and again. And tellingly, many in this space, it's a matter of disproving a hypothesis or refuting a theory, while for us, it's a constant fight to be seen as capable, intelligent as the status quo. And here's Luke Stark and his co-author talking about emotion recognition technologies in a very recent paper. He says, listen, the lack of consensus on the theoretical, underlying theoretical construct, what is emotion, raises the question of whether it's ever ethically appropriate to develop or deploy such systems for public consumption. And finally, the AI Now report big kind of policy think tank, they didn't go so far as to say that we shouldn't do research on automatic affect recognition, but they did call for its banning its use in important decision making. Right. On the other side of the scales is a kind of permissivism, I think. And there are a few people who explicitly kind of come out and endorse this, but the proof, I guess, is in the pudding, which is that there's been an explosion of of facial sentiment analysis research in computer vision. It's like it was a hot area for a long time. The basic idea here is that, listen, facial sentiment analysis is a kind of early science, right? Yes, it might be inaccurate for certain subclasses. Yes, we don't really know exactly why it works. But, you know, machine learning does this all the time. It finds hidden correlations. And we don't really need a pre-existing theory in order to benefit from the use of these algorithms. The prediction is enough, right? And second of all, the kind of risks of facial sentiment analysis are really just a policy problem, right? And you know, there's a moral division of labor between scientists and policymakers. And scientists shouldn't really worry about the kind of ethical risks of these technologies. They should focus on perfecting them, of making them as robust and unbiased as possible. And then it's up to regulators to impose restrictions on companies or scientists to ensure that the kind of ethical risks that we imagine these things have are constrained and minimized, right? You can see there, this is just a list of, this is a recent review of, a recent review of kind of various state-of-the-art emotion classification techniques that have come out. And this list goes on forever. There's, you know, 20 or so recent papers in the last 5 years. I want to suggest that that there's two dimensions of concern going on here. You know, one is there's a question about the scientific plausibility of facial sentiment analysis, right? And there's another dimension, which is whether or not the benefits of pursuing this research are outweighed by the risks, right? And I think everyone wants to say, and I think you can think about these two dimensions of concern for any research project. But in the context of effective computing, I think most people are going to say Ai Phonology sits somewhere down here, right? Very risky, low benefit, pretty implausible that it will work. Facial sentiment analysis sits somewhere in the middle, more plausible, in fact, maybe much more plausible than Ai Phonology, and with more benefit, right? And maybe much less risk. You might think that the risks of textual sentiment analysis are roughly equivalent, but it's more scientifically plausible. We know more about the way in which sentiment can be assessed in text, right? Rather than just simply from reading facial expressions. And then you think about something like ordinary machine learning, like radiology diagnostics, very scientifically plausible, and the benefit to risk ratio is looking really good. Okay. And this is not a new thought. If you're a philosopher of science, you will, you know, especially one who has been kind of indoctrinated by the last 20 years of philosophy of science and the values in science literature, you're going to say that the standards of evidence should go up when the consequences of being wrong are more serious, right? So, you know, this is familiar from Philip Kitcher or Kristen Schrader-Fisher-Perret or Heather Douglas. And so the threshold for pursuing projects is going to be a function of both the ex-ante scientific plausibility of something and the balance of the benefit-risk ratio. And then the question is, once we've set how plausible something is and what the expected risk-benefit ratio is, well, then we need to think about, well, what's the threshold for allowing the pursuit of that research? And I think the difference, I think one kind of fundamental difference between the permissive view and the abolitionist view is that they just have different thresholds for thinking about what the balance of those two issues should be. So the permissivist is going to say, oh no, okay, not Ai Phonology, but pretty much anything else is permissible as a research project, right? Whereas the abolitionist is going to have a much more tightly confined view and say, listen, we need to be really sure about the particulars of that this research is going to yield benefit and that it is scientifically plausible before we kind of engage in it. Right? And here's my kind of basic intervention here. It's to say, listen, I think abolitionism, there's a way to resist abolitionism, right? Because abolitionism is a strong pill to bite. It means giving up on all of the promises of a lot of effective computing because automated emotion recognition is kind of foundational for a lot of different things that we might want to do with effective computing, especially in robotics or in anything that isn't kind of simple textual analysis. Right? And I think one way to resist abolitionism is to point out that it's focused on attacking the plausibility and the benefit-risk ratio of facial sentiment analysis, right? So it's mostly been focused on attacking the plausibility and showing the benefit-risk ratio is not good, right? But I think it's also got to respond to the arguments made for a permissive threshold, for saying it doesn't matter that it's not plausible and that it's unclear benefit to risk ratio, or that the risks look like they might even outweigh the benefits. Because the permissive view is to say, listen, those things don't matter. We should have really broad latitude, right, for investigating things at the scientific or research level. And I think one way that I think this is really useful is thinking about the ways in which permissivism's argument for its threshold might fail, might illuminate pathways for reforming facial sentiment analysis research, or strengthen our reasons for abolition, right? It strengthens the case and gives us strong reason to think that actually this isn't really worth the harm that it might cause. And so the question is, where do we set the threshold, right? Ultimately. And I'm not going to set the thresholds in this talk, but what I am going to do is talk about the kind of two components of the argument for permissivism and show that they rely on two kind of idealizations that I think are false, right? So the first, there are two parts to this, right? The first is that the permissivist says that we should tolerate low benefit to risk ratio in science because the context of science is basically just, right? Like in particular, right, our societies, are mostly progressive. They're racial, racial and gender injustice is mostly this historical artifact, and that we're dealing with, some of the kind of law effects of it, but it's not, ultimately when we produce a technology, it will be implemented in a way that doesn't perpetuate racial or gender injustice. Second, it has a kind of commitment to the liberal ideal, which is that there are no real differences in the needs and capacities of people by gender or race, etc. that any kind of reference to differential capacity is kind of inherently suspect or undermines the foundations of the liberal order, right? And the third, I think, is a kind of utopianism or a Panglossianism about science, which says, listen, in the long run, we all benefit from scientific knowledge. And so it's in our interests, all of us, even those people who are pretty marginalized now, to allow pretty unfettered scientific investigation, because in the long run, that will end up benefiting us all, right? We'll come back to the second set, So I think it should be no surprise, but I think the first one of those is just false, right? I mean, our societies are not, injustice is ongoing. It's not merely historical, right? We continue to have huge inequalities based on race, gender, socioeconomic status. There continues to be, an unacknowledged diversity in people's needs and capacities or requirements for support, right? You think about the experience that disabled people have had or continue to have in our society, have had throughout the coronavirus pandemic. The recognition that there are people who have differing needs, perhaps greater needs in some respects than other people, and differing capacities, right? Is a real source. The blindness to those differing needs and capacities is a real source of injustice. And I think also, even though officially, no one endorses this view, there is still a widespread, persistent belief in a kind of natural hierarchy of races and sexes, right? This is often not explicit, right? But I think that there's a widespread willingness to believe that there are kind of fundamental natural, that there's a fundamental natural hierarchy, right? And what this kind of culminates in is this ongoing injustice infects the creation and application of facial sentiment analysis in two ways, right? The first is that it distorts the inequalities and the diversity in need distort the inequalities and the belief in natural hierarchies distort the training data, right? So you end up with unrepresentative training sets, right? Because people don't have the same access to the resources to contribute to the data set, or they're not included in the data set because they're inaccessible. You also have kind of pipeline biases. So some people, some people are going to be overrepresented as angry because their lives make them angry, right? Or they're going to be overrepresented as sad because they are genuinely more depressed, right? And those things are going to be a function of race and gender and disability because our society continues to treat those poorly. And just in a kind of like, in a really simple way, C infects labeling data because people continue to have implicit attitudes about implicit reactions to people of different races and genders, right? And so you end up with human labeled data that is fundamentally or biased, right? The second is that it affects the distribution of risks and benefits for facial sentiment analysis, which we can talk about in a second, right? So the other thing that's important to note is that our societies are really heterogeneous, right? And that's something that is not acknowledged by the permissive view, or it goes under acknowledged, right? So there are big cultural differences within societies. Multicultural societies have many individuals from different cultural contexts, and that can have a huge effect on the kinds of affect that people experience and also its presentation, right? I have been socialized in all sorts of different ways not to experience the affect of, the affect of sadness, right? and also not to present it in various ways, right? And so that's gonna have a big effect on the kinds of training data that are available to us, and also the kind of base rates of affect in societies. And the second thing is that the differences in needs and capacities within societies can be really stark, right? So, our needs and basic capacities do differ in important ways, right? So people who are physically disabled need different physical infrastructure to realise the same kinds of functioning, right? Similarly, men and women have, on average, different caloric needs, right? Now, this is an important point that's been made by the political philosopher Amartya Sen, right? And ignoring those facts, and people who can get pregnant require obstetric services, for instance, right? So ignoring those facts ignores fundamental differences in our resources and needs, right? The second thing, and similarly with race and gender, which can kind of influence our educational attainment, our income, our health, right, because of the prior injustice. And finally, it's not true that we all benefit from the knowledge generated by facial sentiment analysis research, right? Or at least we don't benefit equally from it. So most facial sentiment analysis provides small conveniences for the already advantaged on the benefit side of the scale, right? The benefits are things like tone assistance or automating the monitoring of your employees if you're in the managerial class, or meta tagging social media, right? Now, of course, there are particular use cases where that's not true, where the benefits are really big, right? So assistive tech for neurodivergent people or low-cost AI therapy, right, might be two cases which look really good on the benefit scale. But in general, they're special cases, right? And the other thing, the thing to note is that the risks of facial sentiment analysis implicate the vital opportunities and needs of disadvantaged people. So affect for surveillance is going to end up targeting the worst off. So people who are in low-wage jobs are going to be subject to affective surveillance, right? Ensuring that they're smiling when they see a customer, right? That they're, that they are, treating, that they're not, moping around the showroom floor, right? Similarly, incarcerated individuals are going to be subject to automated classification of whether they are angry, right, or depressed. And the consequences for predictions are going to be really severe for those people, right? They won't just be small removals of convenience, but they're going to be things like losing a job or spending more time incarcerated, right? And that's likely to compound explicit and implicit discrimination and disadvantage, right? So the second kind of big question, the second big component of permissivism is to think about, well, why does it tolerate low ex-ante plausibility of these theories? Well, it's because it thinks of the conduct of good science in a kind of very idealized way, what philosophers of science would call the kind of value-free ideal of science. And that's in kind of three ways. One, it treats science as a mostly empirical enterprise where you take data, you suck data in, and then you spit theory out, right? Without kind of thinking about hypothesis forming and then testing a hypothesis. Instead, you just kind of suck the data in and it spits out a prediction or a theory, right? The other is that they think of science as morally insulated, right? So the choice of research topic is scientific, not moral, right? And moral values should be explicitly excluded from the choice of scientific topic and methods. The final thing is that they think that external restrictions impede science, right? That the best kind of science is science that's done freely, quickly, and with wide dissemination, so that science can be reproduced, so that the latest scientific results can be shared, etc., etc. So it's their basic picture. if you're a philosopher of science, this makes you very skeptical, right? Because good science is mostly theory-driven, right? And there's been this kind of discussion of post-theory science in the context of machine learning, in very advanced machine learning in the context of science. So AlphaFold, for instance, is supposed to be one example of the end of theory-driven science. There's this famous quote from a natural language processing pioneer who said, every time I fire a linguist, the performance of the speech recognizer goes up. Because once you get rid of theory, right, you're not encumbered by the kind of the preconceptions of theory, you can just listen to the data.
Let's make sure we do leave some time for discussion, John.
Oh yeah, good. Okay. So I think a lot of people are I think this is the kind of ethos of machine learning, but I think a lot of people can be pretty skeptical of this, right? And in particular, without theory and without kind of causal inference, machine learning predictions are often not robust. They're vulnerable to artifacts and training test set to artifacts in the training or the test set. This is a particular problem for FSA because Ekman's basic emotion theory is not well validated, or it's controversial at least, right? At least, and so there's some big question about whether it's even possible to infer affect from facial information alone. All right. So one thing that I'm going to discuss here is, I think, assuming, so there's a question, so I think the last two idealizations are also false, right? I'm running out of time, so I'll just say, listen, you can't morally insulate research choices, scientific research from moral choices. And there's good reason to believe that that's true from the philosophy of science literature, right? So the choice of what evidence threshold to accept for theory acceptance is morally implicated. The choice of which method requires balancing expected evidentiary value with all the practical and ethical costs of the method. The choice of project to pursue involves balancing expected epistemic benefit with expected costs. Right? And second, and this might be surprising to some people, there's good reason to believe that actually restrictions don't impede science. And in fact, you can simulate this using, there's a lot of simulation work that's been done to look at the effect of changing the structure of scientific networks that shows that like highly connected, unrestricted scientific networks are actually less likely to converge on true theories than more disconnected or restricted fields. The basic idea there is actually highly connected fields end up kind of chasing the latest fad theory, right? And iterating on small changes in that theory without really innovating. I have a little spiel about what all this means in terms of reform, but I think the basic idea here is, I think we should resist the two poles, the two extremes. And I think one way to resist those two extremes is to think carefully about the specific ways in which the permissive view gets things wrong. In particular, I think the permissive view gets wrong the context of science, right? It also gets wrong the way in which we ought to conduct science. And by thinking carefully about the specific ways in which it does get those things wrong, then it might help us map a reform agenda for FSA that can help us reform the reform the kinds of research we do with facial sentiment analysis rather than abandoning the project altogether.
Great, thank you very much indeed. I applaud you. I'm sure everyone joins me in doing so in their virtual hands. So if you wish to ask a question, and I'm sure you all do, then just pop up your little Zoom hand and I'll call on you. Don't be shy. Come. I'm sure some of you have questions. I certainly do. So I'd like to hear a bit. So you say you're kind of, trying to avoid both the abolitionist and the permissivist positions. But you spent most of the time attacking one rather than the other. And it seemed like extreme abolitionism was also pretty horrible, insofar as it would involve a kind of top-down policing of people's science. But is your thought? Yeah. So might there not be more to say about that?
Yeah. So I think I do not know whether abolitionism actually ends up being the correct position. And one thing to say is, the abolitionists aren't saying that we should ban this by legal fiat. What they're saying is, really, this should be viewed as disreputable science to do, in the same way that Ai Phonology is disreputable. This should have the same kind of stigma attached to it, right? And that's a big problem because there are huge numbers of people who are interested in this, and it's the foundation for a bunch of affective computing interventions. So, my view is you can actually get some of the benefits of facial sentiment analysis, but you need to do it just much more carefully, right? So, for instance, we need to know a lot more about the basics, the science of basic emotion theory. We really need to have a much better model of what the limits are of these facial, the correlations between facial features and emotion, and what the kind of particular causal mechanisms are for thinking about how those limits are constructed, right? And so one thing is just we need better theory, right? The other is to say, listen, we might need to slow down the science here. So, we could, you can do that in a couple of ways. One is when I think some parts of the computer science, the machine learning community have gotten really good at this, which is starting to demand ethics reviews or explicit consideration of the ethical dimensions of work for the big conferences. So NeurIPS has started doing this. And we might also do this for the big computer vision conferences, right? The other thing to do is to hold closed workshops for highly kind of controversial.
Well, I mean, I'm a bit dubious of the kind of less connected networks actually converge on truth better than highly connected ones, and therefore we shouldn't worry too much about constraints. Just because the more like the phonology, right? The AI Gaydar is highly newsworthy and therefore gets reported in high distribution media, whereas the careful scholarly critique of this is not. So it's not really like there's a single graph that represents the way in which. There was a question in the chat which we should have a chance for. Janelle, did you want to sing out your question, or would you like me to read it out for you? I'll read it out since time is tight. The question is about graduate students. How can graduate students apply this kind of reform agenda to their work if they're in an institution, a lab that isn't particularly invested in the social change or self-examination?
Yes, so I think that's a difficult question, right? There are all kinds of institutional pressures not to think too reflectively about the kind of science that you're doing. But but I think part of it is, one, you need to have a really good kind of grasp of the existing theoretical literature on why we think a particular machine learning task is automatable, right? it can't just be that we think we can extract a correlation out of two data sets or a data set, right? That's not good enough, I think, because it's likely to lead to non-robust kind of science. And I think that's within the general paradigm of computer science. In fact, good computer science, the stuff that gets published in really good venues, is careful to do this, right? The other thing is, thinking about the ethical dimensions of this work is actually a big benefit to you as an individual early researcher, because it's become an important part of the kind of flagship or prestige journals, research divisions, universities. So Stanford now has set up a ethical risk assessment for all of its computer science and AI research, right? They have a pre-review. New RIPS, as I said, has an ethical review. And then the big research companies, DeepMind, Facebook, Google, etc. Whatever you think about the ethics of them at the corporate level, their research divisions are explicitly interested in thinking about the ethics of this research. And you can think about whether or not that's a fig leaf for a long time. But it is, I think, a benefit to you to point out to your supervisor or your group that actually it's in their interest to get their ducks in a row here, because it strengthens the work and it strengthens their own kind of prestige within the field. That's a great question, though.
Yeah, I mean, the way in which the power structures are built into the way in which science is done, as well as the way in which it's applied. We have time for one more question. I'm sure there must be one on someone's mind. No. There we go, Daniel.
Hello, can you hear me okay?
Yes.
So thank you so much for the talk. I just actually wanted to quickly ask, because this is also very much up my research interest as well. I think I'm still kind of more, I've been more kind of swayed by the abolitionist view as well. And it certainly affects my reading of developments in this field as well. I was kind of wondering where there is kind of like, I guess I'm more maybe a kind of specific kind of fact that I want to know about is when did this kind of affective computing begin, and what was it origins? Because I remember learning about it first through facial recognition and sentiment analysis as well. What were the kind of like emerging scholars, whether they're computer scientists or people who are thinking about it in terms of ethics and stuff like that? Because I'm just kind of worried, I'm just kind of interested in the kind of the foundation of this technology and what were the kind of fundamental problems that they thought that they could maybe solve with this technology.
Yeah.
And how much that it maybe informs kind of the rest of the trajectory of that field of research.
So the term affective computing comes from a MIT researcher who wrote a book, and her name escapes me right now. But the book is called Affective Computing. It was written in 1992. It's unbelievable that I can't remember the name.
She came and gave a talk at this university a couple of years ago. I can also not remember the name.
So she, as part of the team, recently wrote a paper, and I can send it to you, Daniel, talking about automated emotion recognition technologies and pathways for reform. The other person who is, I think, more of an abolitionist is Luke Stark at the University of Western Ontario. And his scholarly work with people like Jevon Hudson has been, I think, is probably the best and most comprehensive discussion of the kind of background to this work. So those are two places that I would look. Unfortunately, the investigation of the ethics of facial sentiment analysis has not been as strong. There has been a lot of investigation of the ethics of the Ai Phonology cases, because they're, as Christopher points out, they're newsworthy, right? But facial sentiment analysis, apart from questions to do with its bias, it's particularly racial and gender bias, has not received as much attention as it probably should have. So there's an opportunity to think about it pretty carefully.
Great, thank you so much.
Yeah.
Okay, great. So that's really our time. So we should bring this to a conclusion, although if people wish to hang around for a few more minutes, then that's fine. And yes, Laura was quite right. Rosalind Picard is the researcher who we were both shamefully failing to remember the name of.
Yeah.
Extremely prominent scientist.
Exactly.
But let's join me once again in thanking John for that extremely stimulating and provoking talk. And I hope to see you all at future such events. Thank you.
Yeah, thank you, everyone. Thank you, Christopher and Aaron, again.